Hi everyone, and welcome to Sticken with Science. Mr. Sticken, your host, joined today by Miss Shu, of course. Today we wanted to take the opportunity, we have a snow day today, it's freezing cold temperatures, and we wanted to kind of show you guys firsthand
the Mpemba effect.
You might be wondering what the Mpemba effect is. Well, it doesn't necessarily tell us why, but it tells us that warm or hot water will actually freeze faster than what cold water will. And the reasons behind that are still kind of unknown to scientists, exactly why that happens. But we thought that we would take this opportunity to let you guys see it firsthand. Miss Shu, I'm a little parched. Could you hand me a glass of water real fast? Oh, thank you, Miss Shu. A molecule of water? Miss Shu, you have a sense of humor. Hopefully, as everybody knows, water molecules are made of 1 part oxygen to 2 part hydrogen, right? So we have what we call a covalent chemical bond here between the oxygen and the hydrogen. And because of something we call electronegativity, oxygen being more electronegative than hydrogen is, we tend to have electrons staying with the oxygen more than what it's staying with the hydrogen, alright? So yes, we do have a covalent bond, but now we have a hydrogen atom that is positively charged and an oxygen atom that is negatively charged. And because of this, water does something really cool, and we call it intermolecular bonding. We call it hydrogen bonding. Okay, so water has this property of hydrogen bonding, and it's because of this some scientists think that we can better explain
Mpemba.
Alright, so we can get into more detail on that a little bit later. Let's go outside and we'll do a demonstration really fast about how fast hot water really can freeze. Okay guys, here in front of me I have 1 pot of very hot, just boiling water, and 1 pot of cold room temperature water, alright? And so we would hypothesize, based off
Mpemba.
that the hot water will freeze faster than the cold water would. Just how fast you want to ask. Okay, so let's find out. First, we can start with the cold water. Just take the cold water and I will just throw it up in the air and we'll see what happens. Everybody ready? 1, 2, 3. Oh, it just stayed as water.
Wow.
Alright, well, how about we try the hot water next? Let's see what happens here. Alright, is everybody ready? Try not to get any on myself because it is boiling hot water. Alright, here we go. Everybody ready? 1, 2, 3.
Whoa!
Whoa! It's foggy over here. The water froze on the impact with the air around it. How cool is that?
Mpemba.
Effect right before your eyes. Wow! That was awesome, wasn't it? The Mpemba effect right in front of our eyes. You could literally see the water freezing right in front of your eyes. How cool is that? Well, some scientists today actually think that they can describe this effect because of the hydrogen bonding, like what we were talking about. All right, so when water warms up, molecules start moving more, right? So when the molecules are moving more, they're spreading apart, they're taking up more space, all right? And that's why we have liquids versus solids, all right? So when a liquid starts warming up, it takes up more space, and what's happening is those hydrogen bonds are spreading apart, and we're having less repulsion, okay? And so our covalent bonds can actually come together, expelling any energy into the environment. So we're going from the system to the environment. That's an exothermic reaction, right? Okay.
What do you call a bear without any teeth? A gummy bear?
What do you call a guy with a rubber toe? Roberto. Who came up with this, bro?
And so then whenever we start to cool it down, the molecules get closer together, alright? The molecules get closer together, so the dance slows down a little bit, you know what I'm talking about? Like the Friday night at the court warming coming up, slowing down that dance a little bit. Okay. Anyway, so molecules start slowing down a little bit, and then what happens is the repulsion between the oxygens and the hydrogens, it'll increase, okay? It'll increase, and those covalent bonds between the hydrogen and the oxygen and two hydrogens will increase, and what that does when those bonds increase, it's an endothermic reaction. It's taking energy in from the environment into the system, okay? So we call that an endothermic reaction, and all of a sudden it's taking all that energy in, and so it can use that as a cooling mechanism, all right? So that's what some scientists actually think, that's the process that they are using, the theory that they are using to explain the Mpemba effect, all right? So guys, thanks for joining in this week. Hopefully we can do a couple more of these episodes throughout the year. You know, just sticking with science.